What if I told you that everything you believed was untrue, and that Vikings not only survived, but thrived in Arctic winters thanks to ingenious engineering? They did not have modern technology, but their secret lay in a deep understanding of nature and a phenomenal ability to turn its power to their own defense. These fierce warriors and navigators were also skilled builders whose villages were perfect survival systems designed to never freeze. The art of staying warm in conditions where the thermometer dropped below freezing for months on end was not just a household trick, but a matter of life and death for the entire settlement. They turned their homes into veritable fortresses against the cold, using what the earth itself provided. Watch the video to the end to learn how these hardy northerners turned smoke into a heating device and why their homes were designed to never freeze. What if I showed you a time machine that would take you back to the Viking era to see how they built their homes? For these people, a home was not just a shelter from the rain or a place to sleep after a long day. It was perceived as the foundation of life, as protection from a world full of cold, wind, and danger. In the harsh northern conditions, the house was a matter of survival for the whole family. That is why its construction was treated with special attention and respect. It is important to understand that for a Viking, a house was not just a place to sleep, but a key element of survival, a real living organism that breathed and retained heat. Almost all of life took place inside such a house, from cooking to work and rest. Children were born here, tools were repaired, and long winters were endured. The house had to be reliable, warm, and durable. Otherwise, it became a threat to life. Their famous longhouses were designed with every detail in mind to withstand the harshest northern winds and frosts. The architecture was not created for beauty, but for practicality and protection. The houses were built elongated, without unnecessary protrusions and corners. This shape helped to better retain heat and reduce the impact of the cold. The long, low shape of the house minimized the area of contact with the icy wind, which significantly reduced heat loss. The low profile allowed the wind to literally glide over the roof without damaging the structure. This made the house more resistant to frequent storms. Even the location of the entrance took into account the direction of the winds, so that the cold would not penetrate inside. The base of the house was built on a stone foundation or on a wooden frame raised above the ground, which prevented direct contact between the walls and the damp, frozen soil. This was super important for keeping the heat inside. Moisture from the ground could quickly cool the room and ruin the materials. So the Vikings tried to insulate the house from the ground in every way they could. The walls were built using a multi-layered approach, using only natural materials. On the outside there were boards or wattle, which took the brunt of the wind and precipitation. Inside there was a layer of clay, moss, or peat to retain heat. Then the walls were covered with wood again, creating a dense and warm shell. This natural multi-layered approach created excellent thermal insulation without the use of any complex technologies. The materials were available right next to the settlement. The Vikings understood the properties of wood, earth, and plants well. They knew how to combine them so that the house would serve for many years. The roof deserves special attention, as it was, in essence, an additional natural coat for the entire house. It is through the roof that most of the heat usually escapes. Therefore, its construction was approached with particular care. A mistake here could render the entire house useless in winter. It consisted of a thick layer of turf laid on top of birch bark, which served as a waterproof barrier, and wooden lathing. The birch bark did not allow moisture to penetrate, protecting the wooden elements. The turf was laid in dense layers, creating massive protection. Such a roof required a lot of work, but the result was well worth the effort. The turf roof was incredibly heavy and dense, providing both reliable insulation and wind protection. Its weight made the structure stable, even in strong gusts of wind. The house literally pressed against the ground. This was especially important in the open landscapes of Scandinavia. Thanks to its mass, the turf stayed cool in summer, and freezing only on the surface in winter remained an excellent insulator. The temperature inside the house remained more stable. This allowed people to survive the long winter months without constant cold. This effect was achieved without any artificial materials. Moreover, the weight of the roof evenly pressed down on the walls, making the entire structure extremely resistant to hurricane-force winds. This reduced the risk of the house being destroyed during storms. Turf also absorbs sound well, creating relative silence inside. In a noisy and windy world, this was an important advantage. It should be noted that windows, if they existed at all, were extremely small and located high up. This was done to prevent heat from escaping. Large openings were considered dangerous in cold climates. Light was valued, but heat was more important. They were covered with thin plates made of animal horns, leather, or ox blads, which let light in, but protected against drafts. Such materials were readily available and well-suited for this task. Real glass was not used in everyday life. Most of the light and ventilation came through the door and an opening in the roof above the hearth. The layout of houses in the village was also part of the overall thermal plan. Settlements never arose by chance. People took into account the wind, the terrain, and the proximity of water. All of this affected survival in winter. Houses were built close to each other, sometimes forming a semicircle or an elongated row. One house served as protection for another, taking the brunt of the wind. This reduced the load on the outer buildings. The entire village functioned as a single protective organism. Thus, the Vikings built not just dwellings, but carefully designed climatic shelters where every element worked to preserve heat. There were no random decisions here. Every detail had a practical meaning. This approach was formed over centuries of experience. They understood that the strength and warmth of a home did not depend on luxury, but on a deep respect for the properties of materials. Earth, turf, and wood became man's allies. This knowledge was passed down from generation to generation. That is why their homes were so reliable. It was the art of construction that transformed earth, turf, and wood into a reliable shield against the Arctic cold. We would love to hear your opinion. What do you think about this ingenious use of natural materials? Write about it in the comments, and be sure to subscribe to the channel. Want to know the main secret of how the Vikings heated their homes? Hot zones in Viking homes were not just a place for fire, but the energetic heart of the entire dwelling. A true multifunctional life support system. The central hearth, or long fire in the language of researchers, was located right in the middle of the longhouse on an earthen or stone floor. It was a source of heat, light, and a place for cooking around which the entire life of the family and community revolved. The hearth was long, narrow, and slightly raised, lined with stones to control the spread of fire and accumulate heat. These stones heated up during the day and slowly released the accumulated heat during the night, functioning as a huge oven with a long burning cycle. The heat from the hearth was evenly distributed throughout the house, reaching even the most remote corners. For the Vikings, the hearth was not only a functional but also a symbolic axis of the world. It was a place where all family members gathered, where they ate, told stories, and worked. And this constant human presence also contributed to heating the room. The warmth of human bodies and animals, which were often kept in the house, complemented the heat of the hearth. The smoke from the fire was both a problem and part of the heating system. It rose and settled on the inside of the turf roof and walls. The soot remaining on the surface created an additional insulating layer that helped to keep the heat inside the house. In addition, smoke was necessary for preservation. Meat and fish hung over the hearth were smoked, which significantly extended their shelf life, allowing food to be stored for the long winter. Products processed in this way could be stored for weeks and months. Small hears could also be located in distant rooms or workshops, but the central fire always remained dominant and most important. It was the heart of the home, without which life in the Arctic winter would have been impossible. Caring for the hearth was a daily sacred duty on which the survival of the entire community depended. They used dry firewood, peat, or even manure where possible to ensure the cleanest and longest burning possible. The constant supply of fuel and maintenance of the optimal temperature required skill and experience passed down from generation to generation. This hot center of the home was the very hot zone that kept the village from freezing. But knowledge of the terrain was only half the battle. Ready to learn how the Vikings turned smoke into their ultimate weapon of invisibility and warmth? Read on to the next chapter to find out how a sweet treat became a field kitchen. And you've definitely never heard of this unique secret. The smoke corridor, or ventilation system in Viking houses, was one of the most ingenious and yet underrated elements of their architecture. While it might appear to modern sensibilities as a mere opening in the roof, for the Vikings it represented a sophisticated and thoroughly conceived solution crucial for their very survival. They intuitively grasped that expelling smoke and heat without harnessing their benefits was inefficient. It wasn't just a simple method for smoke removal, but a genuine heat exchange apparatus designed to maximize the energy derived from fire. Every piece of wood consumed had to deliver the utmost warmth to the dwelling. The Vikings couldn't afford to squander fuel. Consequently, smoke ceased to be a mere byproduct of combustion and transformed into an integral component of their heating system. They didn't simply vent the smoke, they compelled it to work for them. Instead of immediately dissipating outdoors, it remained within the house for an optimal duration, ensuring the interior stayed warm even during the most frigid nights. This methodical approach significantly amplified the hearth's efficiency. A specially crafted aperture, known as a lara, was incorporated into the turf roof directly above the central hearth, functioning as the primary chimney. Its placement directly over the fire allowed smoke to ascend naturally. The roof's height and contour were designed to enhance the draft without requiring any supplementary mechanisms. The lara was precisely positioned to generate a consistent airflow, allowing the majority of the smoke to rise slowly, preventing it from lingering in the living areas and ensuring relatively clean air for the inhabitants. However, the smoke's delayed exit was a crucial aspect of this system. As it ascended toward the roof, it gradually cooled and accumulated in the upper cavity beneath the turf. This smoke layer acted as a barrier, preventing cold from penetrating the living space below and initiating the process of thermal insulation. This particular phase was vital for heat retention. The smoke prevented the warm air from the hearth from escaping immediately, thus keeping the heat within the house and maintaining a stable temperature, even during harsh frosts. The resulting thermal cushion served as an additional insulating layer, keeping the primary heat concentrated in the lower, occupied areas of the house, ensuring the living space remained the warmest and most comfortable. Simultaneously, soot deposited on the internal surfaces of the roof and walls, gradually forming a dense, uniform layer that further diminished heat loss. Thus, the combustion process itself progressively enhanced the building's thermal insulation. Remarkably, before exiting the house, the smoke relinquished nearly all its residual warmth. Nothing was wasted. Even the byproducts of fire proved useful. This was particularly significant in regions where wood was a limited resource. The roof hatch was often equipped with a wooden shutter or a heavy fabric cover, allowing its position to be adjusted according to weather conditions. During severe cold or strong winds, the opening was closed to conserve internal heat. In milder, calmer weather, the hatch was opened wider to enhance ventilation and expel excess smoke. Achieving the correct balance demanded experience and constant vigilance. In addition to the central opening, houses sometimes featured smaller side slits located lower, nearer the floor. These allowed fresh, cold air to enter, sustaining combustion and ventilating the house. Cold air drew in from below while warm smoke exited from above, preventing significant drafts within the living areas, ensuring natural and smooth air circulation, and protecting the inhabitants. This ingenious design, employing a smoke corridor, demonstrates the Vikings' profound understanding of air and heat dynamics. They instinctively applied the principles of physics without recourse to formal equations, transforming the potential problem of smoke into a distinct advantage through this simple yet highly effective heating system. Maintaining such an intricate system demanded constant attention and care. Monitoring the fire, adjusting the hatch, and regularly cleaning soot were all part of daily life. The reward for this diligence was a warm and well-lit home amidst the frigid Arctic nights. Don't forget to like this video if you believe the Vikings were exceptional engineers. What you are about to discover will transform your perspective on the Vikings. In a challenging climate where the ground froze deeply, the primary concern extended beyond maintaining warmth. It also encompassed managing moisture. Water, whether from rain or melting snow, posed a significant threat to wooden structures and the well-being of the inhabitants. Consequently, drainage systems in Viking villages were designed with the same meticulous precision as their buildings. Special drainage ditches were excavated around each longhouse and, occasionally, around the entire perimeter of the settlement. These ditches were sufficiently deep and wide to effectively channel rainwater and meltwater, preventing accumulation at the base of the walls. The water was directed away from the house, either to seep into the ground or be collected in reservoirs for domestic use. This straightforward yet effective method prevented the soil around the foundation from becoming waterlogged, which would otherwise lead to faster freezing and increased cold penetration. Within the longhouse, particularly if it had an earthen floor, drainage techniques were also employed. Floors were frequently covered with layers of dry sand, gravel, or crushed stone, allowing moisture to drain through. This layer also provided superior insulation from the frozen ground. The incorporation of stone at the base of walls and beneath floors was another facet of their drainage strategy. Stone, being less absorbent and more resistant to decay than wood, significantly extended the lifespan of the house's wooden components. The turf roof itself played an active role in water dissipation. While the turf absorbed some moisture, it was laid over a waterproof layer of birch bark, ensuring water flowed directly into drainage ditches without lingering on the walls. In instances where animals were housed beneath the dwelling, their designated sections also featured a sophisticated system for waste and moisture removal, often incorporating sloped floors or absorbent bedding. Cleanliness and dryness in these areas were critical for animal health and preventing disease transmission. Thus, drainage systems were as vital as heating. Dryness was paramount for warmth, health, and the structural longevity of the building. The Vikings understood that even the most robust heating system would be ineffective if the house rested on damp, frozen ground. Guess what else they utilized to keep their homes warm? Equally as crucial as fire, as a heat source in Viking longhouses was the communal living arrangement between people and livestock. While this might seem unusual to modern individuals, for the inhabitants of the North, it was a logical and essential solution. This cohabitation was not accidental or indicative of poverty. Rather, it was a meticulously calculated architectural and thermal strategy rooted in generations of observation and experience. The Vikings harnessed the natural heat generated by animals as a continuous and free source of warmth for the entire dwelling. In a longhouse, known as a longhous, a distinct section was typically allocated for animals. Situated at one end of the building, it was separated from the human living area by a low wall or a simple partition. This space harbored cows, sheep, goats, and other small livestock that required shelter from the Arctic cold. Leaving animals outdoors in winter was perilously dangerous. Hence, they were housed under the same roof as people, albeit with a defined spatial division. The animals' proximity to the human living quarters allowed their body heat to be utilized most efficiently. Large livestock, especially cows, emit a substantial amount of heat, comparable in intensity to a small stove. This biological warmth rose and gradually permeated throughout the house, mingling with the heat from the central hearth and enhancing the overall warmth of the room. Thanks to this arrangement, the human section of the house received continuous heating from below, ensuring a more stable internal temperature even on the coldest nights. People didn't need to constantly maintain a roaring fire to stay warm, thereby conserving firewood, a valuable commodity in northern regions. The animals thus became an integral part of a heating system that operated around the clock. The partition between the human and livestock areas was not completely enclosed. It often featured openings or was low enough to allow warm air to circulate freely. Simultaneously, odors and mess were mitigated through the use of bedding and regular upkeep. This design fostered a gentle, constant heating effect without abrupt temperature fluctuations, a living, breathing heating system that required no complex technology. Beyond warmth, Living with livestock offered other significant benefits. Having animals under the same roof provided the Vikings with fresh provisions throughout the winter. Milk was used for consumption and for producing cheese and other dairy products, wool for clothing and blankets, and meat served as a strategic reserve. All these resources were readily accessible and protected from the cold and predators. Animal care became simpler and safer under these conditions. There was no need to expose them to severe frost or blizzards. People could feed and tend to their livestock without leaving their warm homes, reducing the risk of injury and frostbite, which was especially crucial during the prolonged winter months when venturing outdoors could be perilous. Fodder for livestock, whether straw or dried grass, was also vital for the dwelling's thermal balance. It acted as an insulator, shielding animals from the cold ground and absorbing moisture. As it was utilized, the bedding slowly decomposed, generating a small but continuous amount of extra warmth, thereby further heating the space. Regular changes of bedding were essential for maintaining animal hygiene and health. The discarded material wasn't simply thrown away, it was gathered and spread on fields in the spring to enrich the soil. Thus, even waste became an integral part of the survival and agricultural cycle. Nothing was squandered. The cohabitation of humans and livestock vividly illustrates the Vikings' pragmatism and ingenuity. They didn't compartmentalize their needs, but integrated them into a holistic system. Warmth, sustenance, and security were intricately woven together. This synergy enabled them to endure the most brutal winters. Through this approach, the Viking home evolved beyond a mere shelter into a self-sustaining survival infrastructure. What if I told you that the placement of every house in a Viking village was a strategic calculation, akin to a military encampment? For these people, settling down began not with individual dwellings, but with a comprehensive scheme. The very layout of the Viking village was part of an ingenious strategy to combat the Arctic cold. It wasn't a haphazard collection of structures, but a meticulously planned architectural complex where every element held significance. Each house offered protection to its neighbor, and the entire village functioned as a unified entity. The primary adversary they confronted daily wasn't just frost, but also the piercing, icy wind capable of chilling any domicile in mere minutes. Consequently, the selection of the village site was paramount. Settlements were frequently situated where nature itself provided inherent safeguarding. Small valleys tucked behind hills or nestled within fjord bends were considered ideal. Such locations offered refuge from direct wind gusts. The natural contours bore the brunt of the elements, reducing the strain on homes and inhabitants. This strategic positioning ensured that even severe winter winds lost their destructive force. The air circulated more placidly and the cold ingress was less aggressive, immediately boosting the community's chances of survival. People could conserve fuel for heating and dedicate their energy to other endeavors, transforming nature into an ally rather than an antagonist. As previously noted, the houses themselves were constructed in close proximity, with scarcely any intervening space. They formed dense clusters or elongated rows reminiscent of a solid barrier. In this arrangement, the first dwelling on the windward side absorbed the element's full force, acting as a shield for the others. Behind it, the wind diminished and the cold's intensity lessened. The subsequent houses benefited from a more sheltered position. This design allowed the entire village to reap the advantages of a proper alignment of several structures. Clustered construction offered another significant benefit. It substantially reduced the total surface area through which heat could dissipate. The walls of adjacent houses effectively ceased to be exposed to the cold air, forming an extra insulating layer. This conserved a substantial amount of fuel, requiring less wood to maintain warmth. The hearth operated more efficiently, and the internal temperature remained more consistent. In the context of a prolonged winter, this was pivotal for survival. Occasionally, villages were built around a communal courtyard or square, with houses arranged along the perimeter, forming an enclosed area. Such a courtyard fostered its own distinct microclimate, where the wind was significantly milder than outside the settlement. This sheltered space was more conducive to daily activity. Artisans worked there, repairing tools, processing hides, and performing household chores. Even in winter, These courtyards remained relatively habitable, reducing the burden on the house's interior rooms. The village layout also considered proximity to water and grazing lands. Water sources needed to be nearby to prevent long treks in the cold. Pastures were positioned for quick access during the brief warm season. Every aspect was meticulously planned for efficiency, effort, and safety. The village's compact nature allowed for swift responses to any issues. If assistance was required, neighbors were close by. If a storm erupted, all the buildings collectively withstood its impact. Space was not needlessly extended. Villages arranged in a semicircle are particularly intriguing. This semicircle often faced the sunniest side, or the so-called sunny slopes, maximizing light and heat capture even during short winter days. Every ray of sunshine was precious. This configuration enhanced the natural heating of the houses. Walls and roofs warmed during the day, slowly radiating heat in the evening. This was another way to judiciously utilize nature rather than directly combating it. The Vikings possessed a keen understanding of their environment and adapted readily. Thus, a Viking village was not merely a collection of individual homes, but a unified, collective defensive bastion against the cold. In this system, each house served its neighbor's benefit, and each person was a component of a shared mechanism. Interdependence was not a vulnerability, but a strength. This is how they conquered the elements, not through brute force, but through intelligence, foresight, and unity. What are your thoughts on this unique system of collective defense? The Vikings' persistence in a harsh climate significantly relied on their capacity to utilize available resources. Unlike southern regions abundant in stone and clay, Scandinavia presented different materials, equally effective but demanding a specialized approach. These natural resources, expertly extracted and processed, formed the foundation of warm and dependable dwellings. Wood, primarily pine and spruce logs resistant to decay and moisture, served as the main building material, framing the houses. Wood boasts excellent thermal insulation properties, and the Vikings adeptly exploited this by crafting tight joints. Stone was reserved for foundations and lining hearths. The stone base protected the wood from direct contact with damp soil and anchored the entire structure, rendering it wind-resistant. Stones also functioned as heat accumulators, retaining warmth from the hearth. Peat and turf were perhaps the most crucial insulating materials. They were cut into squares and laid in multiple layers on walls and roofs. As noted, peat, composed of partially decayed plants, possesses high porosity, making it an excellent heat insulator. Moss, plentiful in Scandinavian forests, was employed as a natural sealant. It was tightly packed into gaps between logs and boards to prevent drafts. Moss not only insulated but also offered antiseptic properties, improving the interior microclimate. Birch bark, peeled from birch trees, was an indispensable waterproofing material. It was positioned between the wooden lathing within the turf layer on the roof. Birch bark repelled water, preventing the wooden structures from rotting and the turf from becoming waterlogged. The interior finishing was also well conceived. Walls could be coated with clay, which not only reinforced the structure but also served as an additional insulation layer. Clay further aided in regulating room humidity by absorbing excess moisture. These materials were free and readily accessible, yet their processing demanded immense labor and skill. The Vikings were true masters of their craft, transforming simple gifts of nature into architectural masterpieces of survival. The remarkable thermal insulation of Viking homes stemmed from their essential operation on the principle of a dugout. Even if not entirely submerged into the ground, the architecture of these dwellings was inherently designed to conserve warmth. People understood the futility of directly battling the cold, opting instead to leverage nature for their advantage. The multi-layered construction and use of readily available natural materials created the effect of a dense thermal cocoon, reliably shielding the interior from frost and wind. This constituted a natural passive heating system, requiring no intricate mechanisms or constant human intervention. The house walls, cloaked in a thick layer of turf and heat, formed a substantial barrier between the warm interior and the icy external environment. These materials trapped air within their structure, significantly impeding heat loss. Furthermore, the turf and peat fit tightly together, almost entirely eliminating gaps. Drafts were a primary cause of hypothermia, a fact well understood by the Vikings. Consequently, walls were constructed not only thick but also as dense as possible. The thermal inertia of such walls was extraordinarily high, meaning they cooled down very slowly and heated up at a similar pace. Even during extreme outdoor cold, or conversely, a thaw, the internal temperature of the house shifted gradually. This spared inhabitants from abrupt temperature fluctuations, maintaining a relatively stable interior, which was especially crucial for health and survival in an unforgiving climate. The turf roof, potentially up to half a meter thick, was the most vital element of thermal insulation. It safeguarded the house from above, where the greatest heat loss typically occurs. In winter, snow accumulated on such a roof, and snow, remarkably, acts as an excellent thermal insulator, creating an additional protective stratum. The roof, a substantial multi-layered shield composed of turf, birch bark, and a timber foundation, formed an almost impenetrable barrier against the cold. Moreover, many Viking dwellings were either partially embedded in the earth or featured sloped walls covered with soil. This design amplified the insulating capacity of the buried structure and harnessed the geothermal heat of the ground. Even during the harshest winters, the Earth's temperature consistently surpassed that of the air, making the ground an additional reservoir of thermal stability. The recessed placement of the house also offered protection from the fiercest winds, a particular menace in the exposed northern landscapes. Within the living spaces, Vikings employed various techniques to retain warmth. Floors were carpeted with dense layers of straw, reeds, or moss. These materials served not only as bedding for rest, but also created an insulating layer between the cold earth and the interior. Traversing such a floor offered significantly more warmth than walking on exposed ground or stone. The internal walls of the house were frequently adorned with animal pelts, hung along the sides and near sleeping areas. These coverings mitigated the chill emanating from the walls, making the space more comfortable. This straightforward yet highly effective solution involved the pelts forming an air gap between the wall and the living space. This air pocket further trapped heat and prevented condensation, a crucial defense against the cold and dampness that moisture could swiftly bring. Leather and wool, time-honored natural materials, had been utilized for millennia as cold weather protection. All these elements combined to create a self-contained and remarkably warm internal ecosystem. Heat from the hearth, residents, and even domestic animals was conserved within the dwelling, leaving little opportunity for cold air and wind to infiltrate. A Viking house was more than just a shelter. It was an intricately engineered tool for survival in extreme conditions. Beyond the central hearth, Vikings utilized other, less conspicuous domestic heat sources that contributed to the dwelling's overall thermal equilibrium. These modest but consistent heat producers were essential for maintaining comfortable temperatures in specific zones. Some homes might have contained small clay kilns or ubans in end or side rooms. These ovens, smaller than the main hearth, allowed for cooking or localized heating without the need for a large fire. They proved convenient for drying garments or reheating food. Of particular importance were the broad wooden benches or bunks that lined the walls of the longhouse. These served as places for sleeping, resting, and working. The benches were covered with thick animal hides, such as bear, wolf, or deer, which acted as excellent insulators. They created a thermal buffer between the human body and the cold wall or floor. During sleep, when several individuals rested side by side, their collective body heat was trapped beneath the pelts. The benches often featured high sides, essentially transforming them into sleeping enclosures. This design helped to retain heat within the sleeping area, rendering it far cozier than an open space. They were, in effect, organic sleeping bags crafted from timber and hides. Furthermore, daily activities within the house also generated warmth. Crafts like weaving, woodworking, or metalworking demanded physical exertion and frequently involved small forges or tools that radiated heat. The incessant movement and labor of the inhabitants, particularly in large households, elevated the ambient temperature. The heavy clothing worn by Vikings indoors also aided in heat retention. Garments of wool and linen, along with layered dressing, formed their personal thermoregulation system, ensuring they remained warm even when inside. Even the hot beverages and food they consumed played a role. Warm stews, ale, or water provided internal warmth, helping the body maintain its temperature without extensive central heating. Survival in Arctic environments demanded not only technical ingenuity, but also a unique approach to organizing daily life. Constructing a warm home was insufficient. People had to collaborate, or the cold would swiftly overwhelm them. Consequently, the collective played a decisive role. A Viking village was not merely a collection of individual dwellings. It was a unified socio-thermal mechanism where everything was interconnected. Every structure and every individual was vital. The overarching objective was to stay warm and endure the winter. The arrangement of houses, their dimensions, and the distances between them were all governed by the imperative to guard against the cold. The settlement was designed to minimize wind exposure, and even the village's location was determined by climatic considerations. A misstep could imperil the entire community. In the severe winter conditions, with minimal daylight, all life revolved around the longhouse. People endeavored to spend as little time outside as possible. The interior space became the hub of communication and activity, where life's most significant moments unfolded. The longhouse fostered a communal environment, sharing not only sustenance but also warmth. The hearth simultaneously warmed dozens of people. The greater the number of occupants, the warmer the space became. The warmth emitted by human bodies was crucial, and a large group of people living together in one room was a significant factor in thermoregulation, allowing for fuel conservation by utilizing one large hearth instead of many smaller ones. This approach proved considerably more efficient. Responsibilities for maintaining warmth were clearly delineated within the community, with everyone understanding their role and executing it conscientiously. This minimized the risk of errors in critical circumstances. Men were tasked with gathering firewood, maintaining structures, and constructing new elements, meticulously monitoring the integrity of walls and roofs. Women were responsible for the hearth, cooking, and keeping the house interior dry, their work directly impacting heat retention. Everyone grasped their role and fulfilled it with utmost responsibility. There were no trivial duties. Any oversight could lead to heat loss, and heat loss posed a threat to life. The storage system was also meticulously planned. Food could not simply be stored anywhere, as moisture and frost could quickly spoil it. Thus, storage was integral to the overall survival strategy. Grain, dried meats, and other provisions were frequently kept in dry, cool pantries, separate from the living areas. This arrangement helped preserve food longer while safeguarding it from dampness. Occasionally, smaller quantities of supplies were placed closer to warmer sections of the house to prevent them from freezing entirely. This method necessitated constant vigilance. People possessed an acute understanding of the balance between cold and heat. The exchange of knowledge and expertise was a vital aspect of village life. Individuals regularly discussed optimal home insulation techniques, sharing observations about materials and construction methods. Any valuable insight rapidly gained traction, and new strategies for combating the cold spread quickly. If a method proved successful in one home, it was adopted by others, fostering a collective wisdom passed down through generations. Mutual assistance was a cornerstone of Viking life. If a home ran out of firewood, neighbors would provide aid. If a roof leaked, they would collectively repair it. Standing idly by was unacceptable. Mutual assistance was not merely a virtue, but a necessary condition for survival. No single household could withstand winter alone. The community as a whole stood a chance of enduring, a truth universally acknowledged. Even crafts were communal. Blacksmithing, weaving, and woodworking were often undertaken collaboratively, either in a shared space or near a house. This not only produced goods but also provided additional warmth. Physical labor warmed individuals and prevented energy waste, with the heat generated by working bodies enhancing the overall microclimate. Even daily chores became part of the heating system. Thus, the The Vikings grasped that fighting the Arctic cold in isolation was impossible. Their villages were founded on principles of collective protection, where architecture, daily life, and social structure were mutually reinforcing. It was a true triumph of community over the elements. This brings us to the conclusion of our exploration into Viking engineering secrets. Their villages were not merely a haphazard collection of buildings, but a living, breathing response to the formidable challenges of the Arctic climate. Ingenious, multi-layered insulation, the shrewd use of turf, the strategic placement of the hearth, and the integration of livestock into the home's thermal balance were all components of a cohesive, passive, yet incredibly effective system. The Vikings did not contend with nature. They learned from it and harnessed its power to their advantage. Their legacy encompasses not only sagas of battles, but also a quiet, profound lesson in coexisting harmoniously with the harshest environments. Which of the Viking engineering innovations do you find most ingenious? Turf roofs, cohabiting with livestock, or smoke corridors? Share your thoughts in the comments, and don't forget to subscribe to our channel to stay informed about new research into the world of Vikings and other ancient civilizations.